Okay, in this video, we continue to solve equation 1, this one, which is second order linear non-homogeneous equation. Okay, equation 2 with g sub t equal to 0 is called second order, it's a corresponding linear equation, corresponding homogeneous equation. Okay. In the previous video, we learned to solve equation 1, or say find the general solution of equation 1. We need to find 3 functions. We need to find the y1, y2, and the capital Y sub t. y1 and y2 are solutions of equation 2, which is a corresponding homogeneous equation of equation 1. And y1 and y2, they form fundamental set for equation 2, homogeneous equation. Then we need to find the capital Y sub t. Capital YT we call specific equation. We know equation 1 have so many solutions. Capital Y sub t, just one of those. This one may not be what you want. Therefore, we need to find a general solution like this. Okay. We already learned one method, which called undetermined coefficient method, to find capital YT. Okay. That method have some limitation. The right-hand side g sub t need to be some special kind of function. For example, sine t, or exponential function e to the 2t, something like that. Because for those kind of function, you take a derivative, they keep the same type of function. Okay. So in general, if your right-hand side is not those specific functions, then that method won't work. Okay. That's another reason we want to learn a new method we call variation parameter. Okay. How this one works? Idea is like this. To find a general solution, we need to find the y1 and the y2 here, right? So they think about try those kind of solution. Suppose you have y1, y2. They are solution of corresponding homogeneous equation 2 solution. So you can try, okay, put constant C1 and C2 there. You are going to see, no matter how you chose your constant C1 and C2, this one will never satisfy equation 1 because they always satisfy equation 2, which means 1 g sub t equals 0. So therefore, we try something like this. The constant won't work. So we try a function. y1 is a function of t. Also, okay, u2t. Okay, the idea is like this. We know y1 and y2. So we're looking for u1 and u2. They both are function of t. Okay. We want to choose u1 and u2 such that capital Y is a solution of equation 1. It's a solution. Okay. So how do we choose u1 and u2? We want to choose u1 and u2 such that capital YT is a solution of equation 1. So we need to take a derivative, put it back in the equation, see what kind of condition u1 and u2 should satisfy it. Okay. So now let's take a derivative. u1 times y1, they're both function of t, so use the product rule. So to give you u1 prime y1 plus u1 y1 prime, then plus u2 prime y2 plus u2 y2 prime. Okay, now we want to choose u1 u2 such that capital Y satisfy that equation 1. So we have only one equation for u1 u2 to be satisfied. Now we have 2 unknowns, so we can pose another condition. Okay, so we want to, okay, you take derivative once, you already got 4 terms. Okay, So we want to choose our u1 and u2 such that u1 prime y1 plus u2 prime y2 equal to 0. Okay, we impose this condition artificially, because we have two unknowns, we only have one equation, so we can pose another equation. Now we pose this equation such that we can simplify our derivation, So by doing so, then we can rewrite y prime t, give you u1 y1 prime plus u2 y2 prime, because this term and plus that term give you 0. We're asking for that. Okay, now let's take derivative twice on this equation. So you got a u1 prime y1 prime plus u1 y2 prime double prime, then plus u2 prime y2 prime plus u2 y2 double prime. Okay, now we're going to put those y prime, y double prime back in equation 1. So we have replace in the equation 1, replace small y by capital Y. We got this. You got a u1 prime, y1 prime plus u2 y2 prime double prime plus u2 prime y2 prime plus u2 y double prime. Okay, let's give you y double prime, then plus p times capital Y prime, which is u1 y1 prime plus u2 y2 prime, then plus q times y. Y is u1 y1 plus u2 y2. We want to choose u1 u2 such that equation 1 satisfied. So right hand side is g sub t. Okay, now let's simplify this equation. First of all, we want to put all the terms with u, u1 together. Wait. Okay, y double prime is u1 prime y1 prime. Here's u1 and y1, sorry. Okay, so the first term with u1 is 1 here. So you got y1 double prime, right? That's the first term with u1. Second term with u1 in this one. Okay, so you plus p y1 prime. Then the third term with u1 in this one. So plus q y1 prime. That all those are the terms with u1 there. You put the common term out, you got this. Then we got all the term with u2, put them together. This is the first one. Okay, so you got y2 double prime plus another one here, p y2 prime. Then the third one was u2 plus y2. All those are all those terms with u2. Okay, so what's term left? The term left is u1 prime y1 prime plus this one, okay, u2 prime y2 prime. That equal to g sub t. Okay. We just from here to here we just rearrange the terms. Since y1, there's no prime here. Okay. Since y1 is the solution of equation 2, therefore the left hand side should equal to the right hand side, so this term is 0, right? Okay. y2 is also a solution for equation 2 here. So this term is a 0. Okay. So let's simplify this equation. We got this. u1 prime y1 prime plus u2 prime y2 prime equal to g. Okay, so what this tells us, this. We want to, if we let u1, u2 satisfy the first equation here, let me write it here, okay. Let me put this way, okay. Then you satisfy those two equations. The first one is u1 prime y1 plus u2 prime y2 equal to 0. That's what that equation is. The second equation is u1 prime y1 prime plus u2 prime and y2 prime equal to g. Okay. So u1 and u2, they satisfy this equation. Now we need to solve this equation, find u1 prime and u2 prime. This is like a linear equation like this. You learn that, like say, ax plus by equal to e, and cx plus dy equal to f. You learn how to solve this system of linear equation, right? They're like this. You can find x by using this formula. The denominator is a determinant of coefficient matrix A, B, C, D. Okay. The numerator will be like, replace your first column by right hand side, E and F, B, and keep the second one, B and D. You can find the Y similarly. We're going to use this formula to find u1 prime and u2 prime. So my u1 prime here is like x in this equation. u2 prime is like y there. y1 here is like a there. Okay. So by using that formula, we can find u1 prime is equal to the determinant, the coefficient determinant is y1, y2, y1 prime, y2 prime. This is our we call it Wronskian determinant. Okay. The right hand side is replace the first column. We're looking for first unknown, 0 and g. Keep the second one unchanged. So this one can be written like find the determinant is y1, y2 prime minus y1 prime, y2. The numerator is 0 times this, give you 0, then minus y2g. Okay. Similarly, you can find your u2 prime. The same way, okay. The same denominator, y2, y1 prime, y2 prime. Then the numerator, you got y1, y1 prime. Then replace second column by this. Okay, so then we find u prime, u1 prime, and u2 prime. You just integrate the right hand side. You can find u1 and u2, right? So therefore, we find out yt. Okay, yt. If you find your u1, you put it here. u1 y1 plus u2 y2. Then you find specific solution. Okay. Let me summarize what we're doing here. In this video, we are going to learn another method to find a particular solution y of t, okay, capital YT, by using the method we call variation method. How this method works. First of all, you have to solve its corresponding homogeneous equation 2. Find y1 and y2. Okay. Then set your capital Y in this form. u1, y1, u2, y2. Then you find your u1 and u2 by using those two formulas. This is find u1 prime and u2 prime. You integrate it. Then you find u1 and u2. Put back here you find your specific solution. This is just a solution. If you want all the solutions, what do you need to do? If you want a general solution for equation 1, C1y1, C2y2, plus capital YT. With C1, C2 arbitrary, you find all the solutions. Okay, now let's look at the example. How do we use the variation of parameter method to find, to solve equation 1? Okay. First of all, let me write down my formula here, okay? So my capital YT here is U1Y1 plus U2Y2, okay? U1 prime is equal to this. Y1, Y2, Y1 prime, Y2 prime. The numerator will be 0G, Y2, Y2 prime. And the U2 prime is equal to Y1, Y2, Y1 prime, Y2 prime. Y1 prime, 0G. Okay, now let's use this formula to solve this equation. This equation is like this. 3 cosecant t. Okay, this is a second order linear non-homogeneous equation. Okay, so you can try to use the undetermined coefficient method. That one doesn't work, okay, for this case. So we'll have to use a variation of parameter. Okay, as we can see, to find specific solution, we need to find y1 and y2. So let's find its corresponding homogeneous equations like this. So write down its characteristic equation is like this. So your R here is positive minus 2i. So that can be written like 0 plus minus 2i. So y1, this is a lambda, okay? You use that formula. 2 is a mu here. So y1 is like e to the lambda t, then cosine mu t. For this case, lambda is 0, right? 0, e to the 0 give you 1. Mu is 2, so cosine 2t. Similarly, y2 here equal to sine 2t. Okay, so we find the y1 and the y2. So to find the capital YT, we just need to find the U1 and the U2. To find U1 and the U2, we need to find the U1 prime and the U2 prime first. Okay. So first, let's find this. Y1, Y2, Y1 prime, Y2 prime, Wronskian determinant. For this case is cosine 2t, sine 2t, and the Y1 prime is a negative 2 sine 2t, right? And this one give you 2 cosine 2t. Okay. Finally is a determinant. Give you 2 cosine square t minus negative plus 2 sine square t. Give you 2. Now let's find the numerator, okay? Okay, we want to find the U1 prime here, okay? So let's find the numerator. Numerator is 0, y2, g here is a 3 cosecant t, and the y2. So give you negative y2. y2 is a sine 2t. So sine 2t times 3 cosecant t. Alright, so my u1 prime here is equal to negative 3 over 2. The denominator is, there's a 2 here, so I have a 2 there. Then sine 2t and the cosecant t. Okay. Okay, before we find, this is u1 prime. Then we need to integrate the right-hand side to find u1. Before we do that, let's simplify this. Okay. So let's use a trigonometric identity. Sine 2t give you 2 sine t and the cosine t. And the cosecant t is 1 over sine t. So you simplify this, you got a negative 3. The 2 canceled, okay. Negative 3 sine t canceled, give you cosine t. Okay, so this is u1 prime equal to negative 3 cosine t. So my u1 here is the integrate of that. Minus 3 cosine t dt. So give you negative 3 sine t. You can say plus c. Doesn't matter. We just need one u1. Will be fine. Okay. Okay, now let's find the next one. Let's find the u2. Okay. To find the u2, we already find this one, right? We need to find the numerator. Okay. So the numerator here is y1 prime, 0, and g, which is cosine 2t, negative 2 sine 2t, 0, g is 3 cosecant t. So give you 3 cosine 2t cosecant t. Okay, by using this form u2 prime formula, so u2 prime is equal to 3 over 2 cosine 2t and the cosecant t. Okay. So next thing we need to do is integrate this. Okay. Before we do that, let's simplify it. Okay, cosine 2t give you this. Use the trigonometric identity to give you 1 minus 2 sine square t. Okay. Then you have this. Cosecant t is 1 over sine t. So this gives us 3 over 2. 1 times that. 1 times, let me write this. Then minus, this 2 cancel with that, minus 3. Sine squared t cancel with sine t, give you sine t. So this one can be written as 3 over 2 cosecant t minus 3 sine t. Okay. So this is u2 prime. So u2 just integrate these things. So you got a 3 over 2 cosecant t minus 3 sine t. Okay. Okay, once you integrate cosecant t, I'm not going to do that. Okay, that will give you ln cosecant t minus cotangent t. Then integrate the second one. Integrate sine t, give you negative cosine t. So you got a plus 3 cosine t. Okay, we find u1 and u2. So that means we find our capital YT. Okay, that's our specific solution. It's u1 y1 plus u2 y2. u1 here, u1 is here, minus 3 sine t times y1. y1 is cosine 2t. Then plus u2. u2 is this whole thing. 3 over 2 ln cosecant t minus cotangent t plus 3 cosine t, that's whole thing is u2, times y2 is sine 2t. Okay, so our general solution here, general solution for this equation, okay, which is a second order linear non-homogeneous equation, is C1y1 cosine 2t plus C2y2 sine 2t, then plus capital Y of t. Okay, let me give a quick summary. To solve this non-homogeneous equation, what do you need to do first? Find y1 and y2, solve its corresponding homogeneous equation. Once you find y1 and y2, then we can use y1 and y2 to find u1 and u2. Okay. Find u1 prime, u2 prime. Integrate it, you find u1 and u2. Put back here, you find capital Y. Then put here, capital Y, just a solution of equation we try to solve. Only this one give you all if C1, C2 to be any constant.